Alright, another characteristic that they ask you about when you're taking a look at these quadratic functions is the domain and the range and the intervals of increase and decrease. And the domain and the range and the intervals of increase and decrease all go off your vertex. So if we come back to example 1 where we're looking at this in vertex form, we already had the graph of this guy. So let me kind of just clean this up just a touch here and make him a little bit bigger so we can see him. So this is our graph of the quadratic 2 times x plus 4 squared minus 7. Alright, so we knew that we transformed, we went over negative 4 and we went down 7. So we were right here, and we knew that that vertex was at negative 4 comma negative 7. Alright, so talking about domain and range first. So domain. Our domain for any polynomial is all real numbers. Okay, in mathematics, it's not very often you get to say the word any or all. But for a polynomial, in this case, when it's categorized as a polynomial, then you know that your domain is going to be all reals. And the reason is because we know these arrows go on forever. Even though they're going up very quickly, they're also coming out gradually. So as it moves out, it's going up quickly. It moves out, it goes up quickly. It moves out, it goes up quickly. So we can keep on doing this forever and ever and ever in the negative direction, and we'll go up to some really high height to get up to the y portion. Same thing on the positive side. We can keep going out on the positive and then rise up. So our domain is all reals. Our range, however, is limited. Remember, our range is our y value. If we look at this graph clearly stops. It doesn't go any lower than this spot right here. Like, that's the lowest this graph goes. I mean, our graph covers all of this area right here on the y. So it has a starting point or a low point. That's why it's called a minimum. Remember, this is called a minimum. So the minimum on this guy is at negative 7. So my range starts at negative 7 and goes to infinity. It starts from that low point and it goes up. Let's take a look at the second one. So looking at domain and range for the second guy. Let's get him over here. Let's make him a little bit larger. Alright, let's kind of spread my screen out a little bit. Alright, so now domain and range. So once again, my domain, this is a polynomial. The domain for a polynomial is all real numbers. Because as this guy goes, and this guy keeps on going like this, as these guys go down, they're also going out. Or more importantly, as they go out, they go down. Because the domain controls the range. Your range, in this case, is, well, in this case right here, we have this spot, which we found out to be negative 8, comma 7, the vertex. So this guy has a high point. This guy is called a maximum. So we don't get any higher than that particular spot. And that particular spot, in regards to the y-axis, is 7. So our range goes from negative infinity up to 7. So in math, just like in English, there's grammar, and so with math grammar, it's grammatically correct for you to put the smaller number first in interval notation, and then put the larger number second in interval notation. So that's why I didn't say I went from 7 to negative infinity, because grammatically it says what we want to say. So if we said 7 like this, comma negative infinity, that's telling me what the range is, but it's not grammatically correct. So we want to put it with the smaller number first and the bigger number second. Alright, so that's range. Domain and range. Now let's go talk about intervals of increase and decrease. So I'm going to change colors. So up to this point I was using blue to talk about domain and range. Now I'm looking at intervals of increase and decrease. Intervals of increase and decrease, remember, are tied to the x value. So when we find our intervals of increase and decrease, we look at this first graph right here, and we say to ourselves, okay, when we're coming from this side right here, when we come from negative infinity, cruising along like this graph is coming down. So our first interval is going to be an interval of decrease from negative 8 to negative 4. Sorry, negative infinity, to negative 4. That function is decreasing. So if we think about it this way on this graph, is, you can kind of say to yourself, okay, basically everything on this, because now we're talking in terms of x. So we're saying from negative infinity out here all the way to negative 4, this function is going down, 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 down. It gets to its minimum, it stops, it turns the corner, so that's the minimum. It turns the corner and all of a sudden it starts increasing. So it's an increasing interval from negative 4 to positive infinity. Now remember, this is kind of counterintuitive because we're looking at the graph going up and down, but we're describing it in terms of x. We're saying that from this spot right here to positive infinity, or from negative infinity to that spot right there. So this would be decreasing, and that would be increasing. All right, next one. So let's take and erase that highlighter real quickly. Okay, we got our red pen back. All right, so we got this spot right here, which is our maximum. And so we know that basically from negative infinity to that spot right there, and then we pick back up and we go from that spot on out. This would be a decreasing interval because my graph is going downhill. This would be an increasing interval because my graph is going uphill. So in this particular case, my increasing interval would be from negative infinity to negative 8. My decreasing interval would be from negative 8, that's infinity, Josh, negative 8 to positive infinity. Remember that we want to be grammatically correct, so we put the smaller number first and the bigger number second. So intervals of increase and decrease along with domain, just kind of a quick refresher of that, and that's that previous knowledge that we've already worked on in other videos, but I wanted to put in a reminder.